Let's say you've got some generic reaction, and it's taking place at 40 degrees Celsius. We have 2x plus y forming 3z. For the reaction, delta S is 87.2 joules per Kelvin. Delta G is minus 45.6 kilojoules. So what is delta H in this case? Take a few minutes, talk with your neighbor. Give this one a whirl. All right, so I'm not going to do the whole problem here for you, but I am going to show you which equation to use. Make sure you're on the right track. So we'll use delta G equals delta H minus T delta S. So we're at a different temperature. And you should find that delta H is equal to minus 18300 joules, or 18.3 kilojoules. I'll let you work on that one on your own. Here's your answer. Let's look at a different one. Actually, okay, let's do this one. I like this one better. So here we have a solubility for lead chloride. We have a delta G for this reaction. Delta G is equal to 27.11 kilojoules. And then given what you know for the formation of the reactants and products in this equilibrium, okay, those are all given here. I want you to calculate delta G of formation for the chloride ion. Once you do that, I want you to calculate delta G, not at equilibrium, okay, if the lead ion concentration is this and the chloride ion concentration is this. Okay, so there's two steps. First one, figure out delta G of formation for chloride ion. Second one, non-standard condition type problem. kitten. Can't yell. You guys get this value?
It doesn't sound like they got that value.
I got 1 thumbs up, so that counts as everyone got it.
I don't think that's how democracy works.
Oh.
But I don't know, you have the PhD, not me.
All right, so this is a non-standard conditions problem where you're given concentrations that can assume to not be at equilibrium. And so in this case, you're going to have delta G, and that's what we're looking for, is equal to delta G naught plus R times T times the natural log of Q. And Q in this case, based on our equilibrium, is equal to the concentration of the lead ion times the chloride ion squared. Okay. Does that help get you started? Yes. I don't remember. The equations that you'll be given are on the practice midterms. Are you guys ready for a demo?
All right, so I've got a compound called calcium carbide, CaC2, and when you add it to water, it makes acetylene gas. So acetylene gas is flammable. We're going to let it build up in the pumpkin, and then I'm going to light it on fire. This demo is very creatively called Exploding Pumpkin. It is kind of loud, so I'm wearing earplugs, but it's not loud like the hydrogen-oxygen balloon. You guys will be fine. So we're going to wait for it to build up. I'm going to keep talking as a delaying tactic. Probably about ready. If you get hit with a piece, not my fault, but I also need it back. All right, are we ready? Yay! Yay! Happy Halloween! Pumpkin this year. We've used this probably like the 6th time. It's just a really good one. Nice, thank you. You are welcome. Thank you. Oh, you're welcome. We do it every year. What's that?
Taking a look at how big the hole in the back is.
Oh yeah, not very
Pretty
big.
small because you have to hold it down.
Yep, yep.
So when you're writing something as a positive or negative, you write DE after it.
Yeah.
What does DE mean?
It's positive. That's the, I don't know.
Oh, positive or negative.
Yeah.
Okay. So it doesn't really mean it.
Not really. It's just a shorthand I have learned, and it's really hard for me not to do it, so I just do it.
Okay.
Yeah.
Gotcha.
Yeah.
Thank you.
Sorry. Thanks for asking.